Okay, so I made a thing. I saw it a second ago. That one. So let's make a test thingy. Put that in there. And it wants to take, so this is a wire freezer. It freezes the value of the wire, if you know what I mean. So if you grab a slider, it wants a value going in, so we'll put that in there. And then it wants a signal to trigger it to actually freeze the value. So if we just, and then it has the frozen value out of here, which doesn't have a name for some reason. I'll fix that. Cool, so doing that doesn't do anything. But then if you turn, oh, you have to be playing time, I think. Yeah, there we go. So moving that doesn't do anything. Then when you trigger the next freeze, it will remember that value until you move around, whatever, and then trigger it again, and it will remember that value. So if you had a signal manipulator, so a signal generator. So if I just have a way of showing what the output is, then so this is giving the usual kind of sine wave-ish value up and down, and if I like trigger it at the top, then it's remembered that value at the top, and then if I trigger it at the bottom, it remembers the value that it was at that point. So let's remake that thing. So when would this be useful? One time it would be useful is if you want to like randomize some value, like maybe you spawn an object. Let's just set that up. Don't really need the grid. Okay, so maybe you want to set the hue cycle of that. If we set it to full, make it modulate, then if we send it we're taking the wrong wire, so we'll try that again. So if we send that different values, it'll hue shift all of the Sculpt colors. So I did that and spray painted it on. If you turn off styles, then you can see what is actually going on. So then if I make a different color like that, and then turn style on again, then this is like shifting all those values at the same time, all those colors. So when you might want to emit this ball and have it like set to a different random color every time. So then you could do this using this. So the signal generator is a way of generating random values, because you can set the minimum range to it will pick a random value within that. Do the same for the maximum range, or that's the maximum, that's the minimum. Then put it to sweep 0, and if I make that again, so it's spitting out a random value in the ranges you specify here every frame. So then when I like do that, now that the value on that frame is the value this will always be, and you could like change it if you wanted to. but that's one way it's useful. So I think I'll reset those and remake this part in the middle. So yeah, I'll just delete that. So let's make a microchip, and we need a value to freeze and when to freeze it. So usually if there's like a main value that's coming in, I just leave it as that icon because it's obvious that's the main value. And then if there's a trigger, I usually put it to that one because it's a lightning bolt. It's just so cool. And then have that one for the output. So the question is, what goes in the middle? So then so you may have guessed we'll be using signal manipulators because it has a freeze output button. So yeah, so let's just demonstrate that. Let's plug these in as normal. Okay, and we'll like spread this out a bit like that. Okay, so that's getting the value. So if we just test what that does, so it's getting the value from there, which is a random value. When I turn that on, then it's turning on the freeze at whatever value it was. And if we just put that to the output, now if we do it again, oh, that's why. There you go. So you can see it's moving with it, but then when I freeze it, it freezes at whatever value it was. Like that. So that's how freezing works. But we don't want to just do that. We want to have two of these, so that when we press that, the other one will start. One of them will unfreeze and start receiving the live value, and the other one will freeze and use whatever the current value was. So we'll do that using a selector. So take the value into there. By the way, if you're holding a wire and then you hold L1 when you put it into an input, then you'll be holding a new copy, a new wire from the same place. You can plug into the other one. It's pretty handy. So they'll both be powered and they'll both be going out to here. So they'll actually, the problem is if we wire both of them into the same port, then they'll affect what the value is. So if we look at what happens, so if we just plug them both in, then it will be on override mode, and overwrite. Overwrite looks just like an OR gate, and an OR gate actually. So if I wire it the same way, it's just, so this thing is equivalent to that thing. So if I have some value, then it's going to spit out the highest value that's coming into it. That's what an OR gate actually does. So it will ignore this, but then if I make that lower, now it will use this. And that's you can see the value being exactly the same for the port and for the OR gate. But that's not what we want, because if we have like this one frozen at 0.7 and this one frozen at 0.2, then this is the live one we want. We want to send out this value. Then if we just plug them both into the same node, then it'll still be sending the old one because the old one was higher, a higher value. So so we actually need extra nodes. Actually, we could probably do this a slightly different way to the way I did it before. So let's use a selector. So first we'll get this bit working actually. Let's get a value slider and make it like that. So you can see what each is actually storing at a particular time. So you can see if the freezing part works. So by default we want the top one frozen, and then when we change we want the bottom one frozen and the top one not frozen, because the selector will send out a value, send out a signal from only one of these channels, and you can set it using different methods which channel is the active one sending a value. We want to use the move to next output. So when we receive a thing from here, we will move to next output. So it will start on A. So if I run time, it will start on A. Then when we send it a signal, it will go to B, and then A, and then B, and that's what we want. But that also means so it's currently on B, so B is frozen, so that value is frozen there, and then I'm going to change it, and now that value is frozen and that one is live. So if we grab it when it's low, so now that one's that low value and that one's live. So that part is working, but we want to send out the correct value. What if that one is a negative value, and that is 0, it will still send 0 instead of the negative value. So let's add a node like that. And this one will take this value, and we'll have another node, and that will take that value, and we'll only power one of these nodes. So when this one is frozen, we want that same value to be sent out, and when this one is frozen, we want that value to be sent out. And then we wire it like this. But instead of using override, because that would still send a 0, because this will still send a 0 even though it's unpowered, because that's how it works. So then if this is a negative number and that is 0, it will still send a 0 if that is the live value that we want. So actually we want to change this to blend mode. So what does blend mode do? We'll change this to blend mode and find out. And we will get some switches. We don't need that. Oh. And use those to power the values. So if they're both off, oh, we need to play time maybe. Oh, remember, if you're using value sliders to display a value, you've got to be able to have the range in here, otherwise it will clamp it to the minimum and maximum. So now that's sending minus 1.6, and let's say that's 3.2. That one's sending 3.2, and if they're both on, then it sends and the average of both of them. So if we make that 0 and make that 1, that will be 0.5 because it averages them out. But also So this is 0. If I turn this off, if I grab that, if I turn this off, it will still be sending 0. So this is still getting 0. However, it's now not being averaged with the 1 and the 0 and averaged out because it is weighted. It's probably too small text to read on there, I think. But it's weighted depending on the power the source gadget has. So if you power it off like this one, then it won't be used in the averaging calculations at all. So then you just have 1 divided by like plus nothing divided by 1 is 1. So if I had another one like this and made it add 2, then 1 plus 2 is 3 divided by 2 to get the average, that's 1.5. But then it's 0 plus 1 plus 2, which is 3, but divided by 3 because it's got 3 input numbers now, and that comes out 1. So hopefully that makes sense. So we're going to use that to our advantage here. So we turn this one off, and it's not affecting the value this is sending out. It's only coming from that value there. So now let's see what happens if you play time. So we're currently frozen on the top one. Okay, and that's sending out 0.99. And if we change that for a number displayer, like that, then we're getting that 0.99. And it isn't affected by this other number changing all the time. But then if we get like a middle number here, 0.68, then we're getting 0.68. And then a low number, that's 0.9, and we're getting 0.9. So that's how you do a wire freezer. That makes sense. Any questions about that? So now if we use that logic, so if you use that logic to emit in this object over here and emit it and stuff, then it should work. So if you just stamp that on there, then copy that in there, and we'll just put on an in-scene number displayer. So we can see what value it picked. We'll do as we did before, we'll make this random. And sweep second 0. And we actually want to delay this for 1. We don't want it on the first frame. So we pulse it on and invert it and give it a value. Yeah, so you see it flicker. On the first frame it's off, on the second frame it's on. Oh, it's not really plugged into anything. Oh, that's, wait a minute, I know what it is. Silly, there we go. So it's that number there, there you go. So then, so the reason we're doing this is because the first number, so if we delete that or delete that wire, it will use the first value it gets, and that will be the same every time. So if I do, oh, can't really, I'll try that. So that's the same value every time because this dictates like how far through that it'll start at. So it will be the same value every time. On the second frame, it will jump to a new random value. So we need it to be off the first frame and then on the second frame. This is what that does. So then it's getting a random value every time, and we will plug that into the hue cycle like that. So now if we make a quick floor, what was I going to do? Oh yeah, so I'm going to emit this so we can see it like all these. We could just make this smaller, couldn't we? There we go. And now that's tiny. There you go. So if we make an emitter, that emits that, and move it down here. So we're getting different coloured balls flying around the place. Fun. Cool.